Bits per second, or BPS. This is the most basic unit for measuring data transfer speed. BPS represents how many individual bits, the smallest fragments of digital data, can move through your connection each second. Imagine a connection running at exactly 1 bit per second. That would mean only a single bit of information travels in an entire second, which is astonishingly sluggish. Consider this: transmitting a single letter, like the character A, requires 8 bits, also known as 1 byte. At 1 BPS, that single character would need 8 full seconds to arrive at its destination. Fortunately, modern networks operate far beyond these glacial speeds, but understanding BPS matters because it establishes the foundation for every speed measurement that follows. Whether you're looking at kilobits, megabits, gigabits, or speeds that venture into truly astronomical territory, all of them ultimately describe how many bits can flow per second through your connection. Kilobits per second, abbreviated as kbps, represents the next step up in our speed hierarchy. 1 kilobit equals exactly 1,000 bits traveling every second. This measurement defined the early days of internet connectivity. When 1G and 2G mobile networks dominated the landscape, most data moved at speeds measured in kilobits per second. Take 2G edge technology as an example. It could achieve roughly 384 kilobits per second, which converts to about 48 kilobytes per second once you account for the 8:1 bits to bytes ratio. At these speeds, loading even simple web pages required noticeable waiting, and sending photos could consume several seconds. The capabilities were sufficient for basic email communication, text-heavy websites, and downloading individual music files, but not much beyond that. While kbps connections have largely disappeared from contemporary networks, they deserve recognition for bringing mobile internet access to millions of users. Those first experiences of seeing images gradually appear on phone screens, pixel by pixel, represented kbps technology at work. Megabits per second, or Mbps, marks the speed measurement that dominates today's internet discussions. 1 megabit equals 1,000 kilobits, or alternatively, 1 million individual bits per second. This unit describes virtually all modern internet connections, whether you're connecting through home Wi-Fi, mobile data networks, or traditional broadband services. The arrival of 3G technology brought a massive leap forward, pushing average speeds from mere hundreds of kilobits to several megabits per second. This transformation enabled entirely new possibilities. Video streaming became practical, social media platforms flourished, and downloading applications shifted from torturous waits to reasonable experiences. Then, 4G and LTE networks pushed boundaries even further, delivering speeds in the tens of hundreds of megabits per second range. However, there's a crucial distinction that confuses countless users. Internet service providers advertise speeds using megabits, while computers and smartphones display download progress in megabytes. So 1 byte contains 8 bits. The math creates apparent discrepancies. Suppose your internet plan promises 100 megabits per second. When you actually download files, your device will show approximately 12.5 megabytes per second, because dividing 100 by 8 yields 12.5. This explains why your browser might indicate a 12 megabyte per second download speed, even though your provider guarantees 100 megabits per second. The connection isn't underperforming, it's simply using different units of measurement. Gigabits per second, abbreviated GBps, enters the realm of truly high-performance connectivity. 1 gigabit represents 1,000 megabits, or if you prefer thinking in raw bits, that's 1 billion bits traveling every second. This level of speed characterizes fiber optic internet installations, 5G wireless networks, and the infrastructure powering data centers worldwide. The difference between megabit and gigabit speeds resembles comparing a bicycle to a bullet train. With gigabit connections, downloading full high-definition movies requires mere seconds rather than lengthy waits measured in minutes. Gamers, content creators, and professionals working with cloud services depend on gigabit-level throughput to transfer massive data volumes instantly. When 5G networks began deployment, real-world testing revealed speeds typically ranging between 1 and 10 gigabits per second. This performance breakthrough enabled applications that seemed impossible previously: cloud gaming with imperceptible latency, streaming video at 8K resolution, and remote computing scenarios where the processing happens miles away. At these speeds, data doesn't simply transfer, it flows continuously like water through industrial pipelines under high pressure. Remember the conversion factor when evaluating gigabit speeds? 1 gigabit per second connection translates to 125 megabytes per second in actual download measurements. That means a 10 gigabyte file downloads in less than 1 minute, representing speed improvements that would have seemed fantastical just 10 years ago. Terabytes per second, or TBPS, moves beyond consumer-grade internet into the infrastructure that forms the internet's backbone. 1 terabit equals 1,000 gigabits, or expressed differently, 1 trillion bits per second. While residential connections might deliver 100 megabits or perhaps 1 gigabit per second, technology giants like Google, Meta, and Netflix move data between their server farms at multi-terabit speeds. This infrastructure enables them to stream millions of simultaneous HD and 4K videos without system failures or performance degradation. Consider the raw capacity. A 1 terabit per second connection can theoretically move 125 gigabytes every single second. That's sufficient throughput to download your complete 4K movie library in moments. Or contemplate an even more staggering example. It could download every video uploaded to YouTube throughout an entire day in under an hour. Terabit networks power data centers, undersea fiber optic cables spanning oceans, and the major internet service providers supplying connectivity to entire nations. Research laboratories have pushed even further. In 2022, scientists achieved speeds exceeding 1.88 petabytes per second, which equals 1,800 terabits per second. That represents enough bandwidth to simultaneously stream every single video hosted on YouTube. Petabits per second, abbreviated PBPS, represents speeds beyond anything ordinary customers encounter. 1 petabit equals 1,000 terabits, or if counting individual bits, that's 1 quadrillion bits flowing every second. Even global technology infrastructures rarely operate at this level. At this scale, we're no longer discussing internet speed in conventional terms. Instead, we're examining global synchronization of information. To grasp the magnitude, 1 petabit per second equals 125 terabytes per second. In just 1 single second, you could transfer Netflix's entire content library or effortlessly back up everything uploaded to YouTube during a full day. Japanese researchers demonstrated a record-breaking 1.02 petabit per second transfer in 2025 using advanced fiber optic technology. That performance exceeds average home internet speeds by 10 million times. At these velocities, physical distance becomes less significant. What matters instead is maintaining data integrity, keeping those massive flows stable, error-free, and synchronized across global networks. Exabits per second, or EBPS, enters theoretical territory that current human networks haven't reached. 1 exabit equals 1,000 petabits, which translates to 1 quintillion bits moving every second. This speed exceeds anything that internet providers, cloud systems, or fiber networks currently deploy anywhere on Earth. However, it represents a target for future developments in artificial intelligence infrastructure, space-based communication systems, and quantum networking technologies. To visualize the capacity, 1 exabit per second equals 125,000 terabytes per second. That's sufficient to transmit YouTube's entire contents, every video ever uploaded, in mere seconds. Imagine synchronizing all worldwide cloud data instantaneously between continents. That's the vision driving exabit networking research. At this range, traditional physical cables become limiting factors. Researchers are exploring alternatives: light based data transmission, quantum teleportation concepts, and satellite laser communication links capable of handling these speeds without conventional fiber infrastructure. While terabit speeds power today's internet backbone, exabit speeds could eventually enable planetary scale neural networks, the kind required for global artificial intelligence systems, real time Earth simulation, or connecting Mars to Earth with minimal delay. Zettabytes per second, abbreviated ZBPS, ventures beyond any existing infrastructure. 1 zettabyte equals 1000 exabits, or 1 sextillion bits per second. Not even the combined global internet traffic approaches this level. Current estimates suggest the entire internet transfers just a few hundred terabits per second, which falls trillions of times short of 1 zettabyte. For perspective, 1 zettabyte per second equals 125 million terabytes per second. In a single second, you could duplicate every piece of information humanity has ever generated: videos, documents, programming code, databases, with capacity remaining afterward. Yottabits per second, or YBPS, reaches speeds where normal comprehension breaks down. 1 yottabit equals 1000 zettabytes, or 1 septillion bits every second. Let that magnitude settle in your mind. This isn't merely fast, it transcends imagination. At 1 yottabit per second, you could theoretically download the entire internet in under 1 second. No fiber cable exists, no satellite constellation. Not even today's experimental quantum internet prototypes can approach this. We're discussing theoretical speeds that might only become possible through quantum data transfer or neural level communication technologies in the distant future. Today's 5G networks peak around 1 to 10 gigabits per second. A single yottabit per second connection would operate trillions of times faster than that. At this point, we're no longer merely transferring data, we're transferring knowledge itself, raw and instantaneous. If understanding storage units interests you like these speed measurements did, watch my video explaining digital storage units. And make sure to like and subscribe, and stay tuned for more. Thanks for watching.